So, welcome, Matinik. So, our next topic is all about general to particular solutions. Based from the previous uh, topic, the only difference that particular solutions has an initial condition. So, but the process is also the same. So, in this case, we have given dr over r is equals to negative 4t dt when t is equals to 0, and also r is equals to r sub o. So by this, from the first example, is already variable separable, so we can already integrate it. So from the left side, so we can integrate it from and from the right side. And then by integrating dr over r, we will have ln of r is equal to the integral of negative 4 dt is equivalent to negative 4 t raised to power rule. So 1 plus 1, that's 2 over 2 plus c. We can simplify it further. So we will have ln of r is equivalent to negative 2 t squared plus c. By taking the exponential of both sides, so I'm just taking the exponential of both sides. So we will have e raised to ln r is equivalent to r is equal to exponential of negative 2 t squared plus c. But this one, it is also equivalent to, so I'll just put right here. So I'll just simplify the right side. So we will have exponential of negative 2 t squared times e raised to c. Just use loss of exponent. So loss of exponent. So we will have, so by the way, this one is just a constant. So we can say that this is also equivalent to C. So further simplifying the equation, we will have R is equal to C times exponential of negative 2t squared. So we have initial condition that t is equals to 0 and r is equals to r sub o. So t I'll just substitute 0 to t and then ro to r. So we will have ro is equal to c exponential of negative 2. Our t is equals to 0, so 0 squared. So this part will become 1 because e raised to 0 is equivalent to 1. So we will have r sub o is equal to c times 1. Therefore, the value of r sub o is equal to c. So we will substitute r sub o into our equation. So we will substitute, so just highlight it, red. So this one, we will substitute our r sub o into our c. So we will have r is equal to our r sub o, which is r sub o exponential of negative 2 t squared. So this is our answer. Next problem. So I'll just change my ink. So our next problem, a more complicated one. So we are given that 2y over 1 plus y squared dy over dx equals to 1 over x. When y of 2 is equals to 3, meaning we will substitute this one for x, then this one for y. So we have an answer, y is equals to square root of 5x minus 1. So this is, on our second problem, this is already variable separable. So we can integrate both sides already. Sorry. So I just cross multiply dx to the other side. So just mistake. So I'll transpose dx to the other side and then I will retain dy. So we will have 2y over 1 plus y squared dy is equal to 1 over x dx. Take note that integral of ln u is equivalent to, uh, sorry, we know that integral of dx over x is equivalent to ln of x plus c. So in this case, we will just integrate both sides. So on the right side, we know that dx over x is equivalent to ln x. And then from the other side, we will just use substitution first, so we will know if it has a correction factor or not. So first, I'll just change my ink. Then I'll let u. So we will have is equals to ln of x plus c. So first, I will let u is equal to 1 plus y squared. So taking the derivative of that, we'll have 0. The derivative of 1 is 0. And then the derivative of y squared is 2y dy. So we will have du is equivalent to 2y dy. And then I will change our, our y with our u's. So we will have integral of our 2y dy is equivalent to du all over our 1 plus y squared is u. So this is equivalent to integral, which is equivalent to ln x plus c. So we will have integral of du over u is equivalent to ln of u is equal to ln x plus c. But first, we will change our u with our u's with our y's. So our u is equivalent to 1 plus y squared. So I'll just use ln 1 plus y squared is equal to ln x plus c. So next is, I'll just take the exponential of both sides first. So taking the exponential of both sides, we will have 1 plus y squared is equal to exponential of e to the ln x times e to the c. So this is just a constant. So therefore, I can conclude that this is also equivalent to c. So I'll have 1 plus y squared is equal to, so e to the ln x, so that's just x. Then e to the c, which is c, equivalent to c. And then we will have this 1 plus y squared is equal to c over x. Then I will just substitute, to solve our c, I'll just substitute our initial conditions, that y of 2 is equivalent to 3. So I'll just substitute this for x, and then I'll just substitute this one for y. So I'll just substitute. So 1 plus y squared, our y is equivalent to 3, then squared is equal to c, quantity, our x is equivalent to 2. So therefore, we will have 1 plus 3 squared, so that's equivalent to 10, is equal to c times 2. Dividing both sides by 2, we will have c is equivalent to 5. So this one, I'll just substitute this one to to this one, to this one. So we will have 1 plus y squared is equal to c times x. So our c is equivalent to 5 times x. This is already the answer. But on our we are given that y, in terms of y. So we will solve for y. So I'll transpose 1 to the other side. So we will have y squared is equal to 5x minus 1. So taking the square root of both sides, I'll have y is equal to square root of 5x minus 1. So that's our answer. Next problem. So next problem is much more complicated problem from the two previous problems. So just so let's start. So from here, it's already variable separable, as you can see. So we will just now integrate it. So integrating both sides. So we will have, we know that the integral of this one is just ln of x, right? So this is, this part of integral is much more complicated. So just answer it. So let u is equal to 1 plus y squared. So taking the derivative of that, we will have du is equivalent to derivative of 1 is equivalent to 0, and then derivative of y squared is equivalent to 2y dy. So you can see we only have y dy here. So we will have a correction factor. So divided by both sides by 2. So 2 will be cancelled out from this side. So we will have 1 half du is equivalent to y dy. Now, now we will change our y's with our u, with our u's. So now let's now substitute it. So integral of y dy, our y dy is equivalent to 1 half du all over 1 plus y squared is equivalent to u. So I'll just take the our coefficient, our constant outside our integral, outside of our integral. So so we will have 1 half integral of du over u is equal to ln x plus c. So integral of du over u is equivalent to ln u. So we will have 1 half ln of u is equal to ln of x plus c. Now, as you can see from this side, we have 1 half ln of u. First, I will use natural logarithm rules. So we have, in natural logarithm, we have this. So for an example, a times ln of x, this is also equivalent to ln x raised to a. So I'll just put this one here. So it will become an exponent of our variable. So we will have ln of u raised to 1 half is equal to ln of x plus c. So by taking the exponential of both sides, we'll have this. So by taking the exponential of both sides, we will have this. So we will have u raised to 1 half is equal to e to the ln x. So that will become x. And then e raised to c. So equivalent, this is also equivalent to this, right? E to c. So e to c is just a constant. So it will become just c. So taking the, uh, by squaring both sides of the equation, we will have u raised to 1 half, that will become q is equal to c squared. C squared is also equivalent to c because it is just a constant. So we will have c times x squared. Now, we will change our u with our variable, this kind of dark. First, I will change out my ink. So we will change our u with our this variable, y variable. So this one, so our u is equivalent to this. So u is equivalent to 1 plus y squared is equals to c x squared. Then, first, I will just substitute our initial conditions. So our initial conditions are the following. Y of 2 is equivalent to 3. So I'll just substitute it. So we will have 1 plus our y is equivalent to 3 squared is equals to c times our x is equivalent to 2 squared. So we will have 1 plus 3 squared, so that's equivalent to 10, is equal to c times 4. Therefore, the value of c is equivalent to 10 over 4 or equivalent to 5 halves. Then, I'll go to this one. I'll just substitute 5 halves into our c. So we will have 1 plus y squared is equal to 5 halves times x squared. Then I'll just transpose this one. I'll just transpose this one to the other side. So we will have y squared is equal to 5 halves x squared minus 1. And then taking the square root of both sides, we will have y is equal to square root of 5 halves x squared minus 1. So you can see our answer is correct. But the problem is we should simplify it further. So we should have an answer like this one. Y is equals to 1 half square root of 10x squared minus 4. So I'll do this. So I'll factor 1/4 from this. So we will have y is equal to, I'll factor 1/4. So quantity. Then I'll put 10 here. So so it will become 10 out of 10 over 4. So 10 over 4 is also equivalent to 5 halves. So 10 times x squared minus. So we have 1 here. So I should put 4 over 4 is equivalent to 1. So I should put 4 here. So taking the square root of 1/4, further simplifying our equation, so we will have y is equal to 1 half square root of 10x squared minus 4. So that's our answer. Thank you, Math-Tinik, and then uh, see you on my next videos.